Welcome to the third and final video in this short series. In this one we'll make just a slightly more complicated animation than we did in the last one. We're going to make this drawing come together. So if you haven't watched parts 1 or 2, it would probably be good to go back and watch those first. In the first one we made a C# component that gives us multiple counters, and in the second one we made a simple animation with those counters. So let's go back into Grasshopper and we'll use the counter component that we made in the first one. We'll add a level of complexity to what we did in the second one, and we'll make a drawing. So first I'll go into top view, and let's get rid of the grid here too. And we don't need any of this stuff anymore. We're going to start from scratch and make a completely new animation. So I'll just reset that counter. This will be temporary. The first thing I'm going to do is paste some curves. All of these curves just make a drawing. If I show this, see where it is, right there. So we're just going to make this drawing. This is just a line drawing. So you can use, if you have a drawing ready that you want to animate, use those. Otherwise you can just head over to the Pavilion website and grab this file with these curves already in here, and you can work with these if you want. The first thing I did with the curves was put them into this entwine component, because we're going to want to give all of these lines slightly different shades of gray. At least that's what we'll do in this animation. There are ways to actually vary the line weight from Grasshopper and in communication between Grasshopper and Rhino, but we're not going to do that here. We're just going to vary the colors. So we'll make some colors darker and some colors lighter, different shades on the grayscale. But the first thing I'm going to do here is, I'm not sure exactly how these lines are ordered at all, and in our animation we might want to actually have it animate from one side to the other instead of just randomly choosing which line to draw next. So let's organize these lines a little bit depending on whether, according to their endpoints, so if either the start of the curve or the end of the curve is in one position, we'll sort them based on that, and that might be confusing, but let me just do it and then maybe it'll make a little bit more sense. I'm just going to get a curve component, and we'll make a little component here, and that will be the input. Let's get our input points from this curve. And the reason I want the endpoints is some of these curves are long, and I'm not sure what way they're oriented. So I just want to pick a point that is furthest in one direction. It doesn't have to be the middle or the end or the beginning, just whatever part of the curve is further, let's say towards the bottom left. That's how we're going to organize the points. So what we need to do that is a deconstruct point component, and we'll deconstruct both the beginnings and the ends of each curve. And we're in top view right now, so we don't have any z coordinates. This is just a two-dimensional drawing, so we just need x and y. Let's add together the x and y's. And then let's make a very quick C# script. And what this is going to do is just pick whatever's smaller. If it's the endpoint that the x and y is added together are a smaller number, or if it's the start. So by adding together the x and y coordinates, and we're looking for the smallest ones, we're looking for lines that are closer to this area than up in this area, and we need to find the smallest, whether it's the end point here, or the beginning point, the start point here, or the end point here. So we just want to choose the smallest coming out here. So this is going to be type hint double, type hint double. In a very short script, we'll just say double b equal to x if y is less than x, b equals y. So no matter whatever is in variable b, it's either going to be, I think x is coming from our start point, y is coming from our end point, so the smaller of either x or y is going to be in the variable b, and then we'll send b out the output. And then we can sort based on that. So these are going to be our keys, and we want to sort our incoming curves here. So that's just a quick way to sort the curves, starting down here and moving in this direction, up and to the right. And output, we'll call this curves. Package that. We'll say sort curves. hide those. And then right now I'm going to get a list lengths. And this is going to be used to partition our list later. So if I get a panel, I just flattened that output. This is telling me how many curves are in each one of these. So this one has 16, this one has 32, this one has 345. And we're going to flatten all of these curves so that we can run them through the animation and draw them all together. But we do want these different branches to have different, not line weights, but kind of like line weights, just different shades. And so the way we're going to do that is, even though we're going to flatten this, we're going to put them back into branches at the end after we've drawn them. And this is going to be our information to help us do that. We're going to use the partition list component to do that. But we'll just let this component sit here for now. I'll delete that, and I'm going to get a curve component. And let's flatten these curves. Actually, let's just get a flatten. And pull these over here. And now this is going to be how many counters we have. So last time we had like 5 counters, or we started with 5 and then we had, I think, 49 different counters because we had a 7x7 grid in the last tutorial. Now we're going to have 1,869 different counters. So let's get a list length. And that's going to be how many counters we have. And we're already way at the bottom, so when we're watching the animation, we can keep an eye on this number to know when the animation is complete. When that number hits 1, then we're done. So we need the list length, but we also need the curve lengths. So let's get another length component, but this time we want this component to measure the lengths of all of these curves, because we're going to divide them up into segments, and each step in our animation, we're going to add more segments to each line, so it looks like the curves are getting drawn in time. So let's get a divide curve component. And if we plug these in, one thing that we can see that we probably want to avoid in this case for this animation is that the segments are very different in size. So of course the larger lines have very big segments and the smaller lines have very small segments. We want all the segments to be about the same size so that we don't have some lines being drawn very quickly and other lines being drawn very slowly. So that's why we want the curve length component, so we can divide each curve depending on a length. And actually, let me see, if we go up here into the curve tab, divisions, divide a curve with a preset distance between points. Let's use that instead. But we do need to put a distance in here. So let's get the average length. And let's divide the average length by some number. Let's get a division component. And we'll say 1 less than 6.000. Let's make them a little bit smaller. Okay, this isn't quite what I want because some of these outputs only have 1 point. So we need each curve to have at least 2 points because we're going to remake the curves with a polyline component. So I'm going to delete this. And let's just set this to 3. And let's get the regular divide curve component. And then let's round. Let's get another division. And let's divide these lengths by the average divided by 3. And so that's going to give us about how many segments each of these curves would have. And then we round this to the nearest, well, we'll round up. So the ceiling component. And then we can divide our curves. Okay, so that's better. So now every branch here has at least 2 points in it. So the smallest ones there will only be 1 segment, and so 1 step will draw an entire line. But for the longer ones, it will take several steps to draw those longer lines. Let's hide all this. And let's simplify the output here. And we could go ahead and let's actually hide this. And let's make some polylines out of these branches. And this, we're going to do this so that we can identify another problem that we can fix. So if we go here to something like this circle, we can see a couple of issues. One is the one that we're going to solve first. Well, actually, no, because the second one is very easy to solve. We'll do that one first. It is that this doesn't even look like a circle because there aren't enough divisions. If we increase the number of divisions, it will look a little bit better. But the other thing is this is a circle here, but it's not closed. And so we want to make a little component that's going to check and see if these are closed curves. And if so, add an extra point to the end of that list that's making these polylines. So we'll do that next, but first let's look at some of these numbers. Like this one here, we can't even tell really what number that is. And so let's just increase these, not too much because it'll slow down Grasshopper quite a bit if we do very small divisions. But let's increase this at least to like the maximum to 20, and let's maybe put this at like 12. And then that's pretty clearly a 9. And then of course if you want a more detailed animation, like a higher resolution thing, you can increase that number more. Actually, let's just go to 14. But again, this circle isn't closed, and we want all of these where they should be closed curves to be closed. So let's work on that next. Let's make a little component here that will take in our curves, or our points. These aren't curves yet. And let's just call this points. I'll hide that. And our curves. So we do need a curve. These are going to be coming from our flattened curved list. And I'll hide this input or display hidden. And the first thing we can check is whether or not these are closed. So we'll make a little component that checks that. Pretty quick. We'll get the endpoints and check the distance between them. Get a smaller than. If it's smaller than some very small number, like 0.0001, then these are the same. These points are in the same position. They're the same points, essentially, which means that the curve is closed. And then let's get a Boolean output. Call this closed. So if this is true, then the curve is closed. We'll just say is closed. And then let's get the branches for all the closed curves. So let's get a tree branch component and a member index. This way is the best way I found to most reliably get the indices for specific objects in a list. We have a list here of trues and false, and I want to get a toggle set to true. I want to find all the indices that are true in this list, and then those are going to be my tree branches. So if we click on that, then we have all of these green ones are all of the closed curves. So let's hide these and these. And for the closed curves, we want to add the beginning point to the end of that list so that the polyline will just automatically make that look like a closed polyline. So we just want to grab the first index from every list of points and merge it at the end of the lists. So we just added an extra point at the end of every list that is closed. So let's hide these. So now we need to know if we don't want to add, obviously we don't want to add an extra point to curves that aren't closed, because then the polyline is going to swoop back around and it will unnecessarily close some of these polylines. So we need to substitute all of these branches with the same branches in this list. So this list is all of the branches with the same branches in this tree. So this tree has all of the branches of points, but we want to remove some of the branches. If I hover over this, you can see that branch number 30, branch number 1768, 1769, 1770, and so on are all closed curves. We need to swap out these branches. So we're going to make a C# component to do that. We'll call this tree. This is our input tree. points. So I'm going to right click and go to type hint point 3D, and we need this to be a tree axis, and we'll call this replace. Okay, and whatever you do, do not plug this into that yet. Don't do that until you've right-clicked here and gone to tree axis. The first time I did this, Grasshopper crashed because unless this is expecting a tree, then this component is going to try to run many, many times because we already have this one plugged in. So make sure both of these are set to tree axis. You can go up here and say type hint point 3D also, and then if you plug it in, it'll be fine. Get back over here. Okay, so now we can keep going. I'm going to open up this scripting component. And so again, what we're going to do is take all the branches from this replace tree and swap them with their corresponding branches in the tree. So that's going to look something like this. I'm going to make a new data tree of points, and we'll call it new tree. New data tree points, parentheses, semicolon. Then let's make a for loop. For int I equals 0, I is less than our incoming tree, the main one, the number of branches in it, in I++. So we want to iterate through all of the branches in our main tree. And for each branch, let's make a new path, a new GH path, based on whichever I we're on. So the branches are going to have the same paths. And then out here, let's also make something called next branch. And this is going to be a list of points. That is going to be the next branch of points. Then we're going to do a conditional. We're going to ask if the path exists inside our replace tree. So we brought in the replace tree that has only branches that we need to replace. So we're going to check to see if those branches exist inside that tree. And if so, next branch is equal to replace dot branch path. But if that branch doesn't exist in the replace tree, then we just take the branch from the tree, from our tree that we called tree. Should have called it something else. So we'll say next branch equals tree dot branch. And then in either case, we'll add that new branch to our new tree by using the add range method. Next branch at path. And then our new tree is going to come out of our output. And it looks like it worked. Let's use these. I'm going to hide this first and use these as our polylines. And then if we zoom in, we can see that now the circle is closed, that little circle inside the sixth is closed, and so that looks better. So let's get points, another point, and we'll just call this points so that we can make this into its own little component to clean up our canvas. Cluster that. We'll hide these. Show that again just so we know what we're working toward. And so the way that we're going to do this is as these counters go up, we're going to add more and more points to the lists that are going to make the polylines. So right now we have all of the points in all of these lists, but we want to start with 0 points, then we'll add one, then more, then another one, then more and more and more. And as we add points, the lines will grow. So what we need to do is let's get a number component and let's call this time. And eventually what's going to go into there, well actually we'll just put it in there now. These are going to be all of our counters. And I'm going to copy this. And we need to graft it and simplify it so that we can match all of these branches. So if I hover over this, you can see the last branch in this list is 1868. And if I hover over this, you can see the last branch is 1868. So as the numbers, there's only one item in each of these branches, and that's good. As it goes from 0 to 1, we're going to add more and more points to these lists coming out of this component. But what we need to do in order to get there is remap the numbers from 0 to 1 to 0 to however many points are in each of these lists. So let's make a little map indices component, a little component that will do that mapping for us. First thing we need is the list length from each of these point lists. And I'm going to disconnect this for now. Actually, no, this is fine. We'll leave it connected. In an integer that is, we'll call this list lengths. And list length is fine. So this is pretty easy. We just get a construct point or construct domain component. So, and then we're going to remap the numbers. So remap numbers. The times are going to be our numbers. And again, instead of going from 0 to 1, we want to go from 0 to 270 for this branch, 0 to 270 for this branch, 0 to 6 for this branch, because these all have different number of segments in them. So these are our targets, and the default is 0 to 1. Then let's just round to the nearest integer. So I'm going to get an integer component. We'll just call this index. That'll be the output for this little component. Remap indices. And we use these index numbers in a series component. So this is going to tell us how many index numbers we need, and we'll put that into the count, and then this will count from 0 to however many we've made it in each of the lists. So the first branch, it's already counted all the way up to 94. So we have 0 through 94 in the first one, 95 different items. But as we go down here, these haven't even started counting yet. And then we'll get a list item. These are going to be our list items. And these will be our points. So you can see the first two branches are these vertical guidelines. And so we've crawled up this far for each of these. And let's get a polyline component. So let's hide these. And now we can hide everything over here. So you can see just those two polylines. And this, don't worry about this warning. Of course, there aren't going to be enough points in all the branches yet because our counter hasn't gotten to them yet. But this is where our partition list comes in. So let's flatten this. And remember this component back here that we had the number of lines or the number of curves in each of these branches. Now we need this. So let's get a partition list. These are the sizes of all of the lists. And our polylines coming out of here are the lists, is the input list that we want to partition. So I'm going to set that to hidden. Or maybe paint, if that's not too distracting. And then the last thing we can do is add line weights, or our faux line weights, just the colors. So let's copy this in Twine. And I'm going to go through and let's just get a color swatch. And duplicate this so that we have the same number. We'll have a unique color for each of the branches, then custom preview. These will be our materials. So now they're all white. Let's make this, so these are our vertical guidelines. I'm going to hide whatever's showing over here, the polylines. So that's our vertical. Our lighter guidelines, our darker guidelines, we'll make, I guess, a little bit darker than this. These are like on the surface guidelines. Then we have 3 different hatches. I think we'll make these like progressively darker. A hatch like that, then a hatch like that, and then a darker, the darkest of the hatches. And then outline, this is like the silhouette. We'll make this very dark. And then the last one is numbers. Okay, that works. but we don't want to be showing those. We want our partition lists so that we can run the animation. And if we click reset, then we have 0 lines. But I think we're ready to go. We can just click play to play our animation. This is pretty slow. I'm going to set the interval to 20 milliseconds, reset it, and here we go. And the last one, just hit 1, so we're done with the animation. And we're done with this whole Row Your Boat series, part of the animation collection. If you liked these videos, stay tuned, there will be plenty more. If you want even more on animations though, consider becoming a member. Go to pavilion.nuluka.com and click join. Members have access to everything, and most content like this is available only to members. So thank you again for watching, and we'll see you next time.